3DIoUMatch, leveraging I/O prediction for semi-supervised 3D object detection. 3D object detection is at the core of computer vision. However, state-of-the-art methods heavily rely on supervision that is often expensive to acquire. In this work, we tackle this issue by proposing a semi-supervised approach to 3D object detection. Our setup is as follows. We assume access to a small set of 3D scenes with full annotation and also a large collection of scenes without any label. We propose a novel SSL pipeline to leverage unlabeled data and improve performance. Our method is based on label propagation from the small label set to the large unlabeled one. Following SES, the previous state-of-the-art semi-supervised method on 3D detection, we adopt the two-stage training setting. We first train an object detector on a small amount of label data. In our experiments, we chose VoteNet as our backbone object detector. We then proceed to a semi-supervised learning stage to leverage all data, as we explain next. We start with describing a naive pseudo-label propagation baseline. As commonly used in SSL works, our method is based on a teacher-student mutual learning framework. To guarantee that the teacher model produces useful supervision signal, samples fed to the teacher network undergo weaker augmentation than those passed through the student. On labeled data, student network is trained as usual. On unlabeled data, the predictions from teacher model will be used as pseudo-labels to supervise the student model. Unlike image classification, detection is a highly complex regression problem where raw pseudo-labels can be very noisy. This leads to our first important observation. Directly using those labels for supervision is suboptimal. Instead, we propose a pseudo-label filtering to get rid of poor quality supervision signals. This is inspired by our recent semi-supervised image classification work, FixMatch. Here, we filter according to two confidence measures, objectness score and top class probability. Specifically, by filtering out proposals with low objectness score, we get rid of background boxes. By additionally filtering based on class confidence, we get cleanly labeled boxes. Now going to our second important observation. Although this filtering is useful, the two confidence measures fail to capture localization quality and thus cannot sufficiently improve the localization accuracy of the pseudo-labels. To that end, we propose to use 3DIoU estimation as a localization confidence in order to filter out badly localized boxes. Our complete filtering module thus jointly filters according to these three metrics. To the best of our knowledge, we are the first to introduce IoU-based filtering in the context of semi-supervised learning in both 2D and 3D detection communities. Here we show the complete pipeline of our proposed method 3DIoUMatch. Our IoU-aware VoteNet predicts bounding box along with the 3DIoU. We append our newly introduced 3DIoU estimation module to the proposal generation module of VoteNet. This module supports many functions. Now let's delve into pseudo-label filtering. Choosing an IoU threshold is not a simple problem, as we demonstrate in this toy example. Here, green boxes represent ground truth objects, whereas pink boxes are our pseudo-labels. With low IoU thresholds, the pseudo-labels are of low quality, but objects are well covered. Keep increasing the threshold, we can get higher quality but lose object coverage. To find a balance between quality and coverage, we adopt a two-step pseudo-label removal. First, filtering with low IoU thresholds to maintain many pseudo-labels. Then we propose an IoU-guided low half suppression. Our LHS set a class-aware self-adjusted threshold, making a good balance between quality and coverage. Finally, we propose to selectively supervise the student predictions, given that our pseudo-label cannot cover all ground truth objects. We perform a thorough evaluation and show that we are able to significantly outperform the prior art, SES, under all label ratio settings. Here we show the comparison on ScanNet and SUN-RGBD with annotation for 10% and 5% of the scenes, respectively. Our improvement over SES is remarkable, especially on MAP 50%. Compared to a naive pseudo-label baseline, our final model consists of filtering, test time IoU-guided NMS, and IoU optimization, all based on our specialized IoU module. Here, we show the considerable improvement brought by the effective filtering mechanism and test time improvements. In summary, we propose a state-of-the-art semi-supervised method for 3D object detection based on effective label propagation with IoU-based filtering. Please check our project page for more details and code.